Hi, and welcome to this finance lecture for Stockholm Business School. My name is Anders, and I will talk about the time value of money, and more specifically, I will talk about the present value of an annuity. First of all, however, we start with some repetition. Johan talked about financial decisions and said that it was about giving up resources today in the hope of obtaining something good in the future. And in order to be able to compare the initial outlay or the resources we give up today with the good stuff we get in the future, we had something called the time value of money. We said that money today is better than money in the future. And why is that? Well, because we have inflation. So for the same amount of money, I can buy more stuff today than I can in 2 years' time. And we also have the interest rate. If I get the money today, I can deposit it to a bank account and get some interest and have more money in the future. And last of all, we have some uncertainty. If I get the money today, I obviously know that I have the money in my hand. If someone tells me that I will get the money in the future, you never know. The company might go bankrupt, your friend might disappear. It might not be very likely, but you never know. So of these three reasons, money today is better than money in the future. And in order to compare money today with money in the future, we had some formulas that Johan showed you before. So we said that to get the future value, or the equivalent future value, so to speak, we took the cash flow today, which would be this one here. We multiplied it with the factor 1 plus r, where r here is the interest rate, or the discount rate, as we often call it, and raised to the power of n, which is the amount of years we want to move this specific value. So we said that obtaining this c today is equally good as obtaining this here, c times 1 plus the interest rate raised to the power of n in n years time. And in your formula sheet it will look like this. Here's the future value. So the future value of some cash flow c is this cash flow multiplied by 1 plus the discount rate raised to the power of n, which is the amount of years you want to move it. However, Johan also talked about the present value, which is basically just the inverse. So instead of saying that the equivalent future value of some cash flow, we said that this is the equivalent present value of some cash flow. So if we take this cash flow that we will receive in n years from now, and if we divide it with 1 plus r, where r is the discount rate, raised to the power of n, which is the amount of years until we get this cash flow, we get the present value of this cash flow. And the present value of this cash flow is the equivalent cash flow today compared to the cash flow c in n years. So it's equally good for me to get this here, the present value, today as getting c in n years. If you for one moment forget about inflation and the uncertainty, you can think of it as, if I get the present value today, I can deposit the money on a bank account and get r, or some interest rate, for n years. So basically, if I deposit c here, I will have this in n years. Or the other way around, if I would deposit the present value here today and get c, or get the interest rate for n years, I will have c in the future. That is why they are equivalent, so to speak. Now we can move on because you have already learned about this, but we can go on to the interest rates or the discount rates. They should reflect the inflation, other investment opportunities, and risk. So, as we talked about earlier with the time value of money, the interest rate you use or the discount rate should reflect the inflation. It should reflect what other investment opportunities you have. Could you deposit your money in another bank account? Could you perhaps purchase a car and gain some money on that? Could you, whatever, you can buy stocks, you name it. And last of all, risk. With this specific investment decision, what risk do you have? Is it a risk investment or is it a less risk investment? Generally, deposit money in the bank account is not so risky, it's less risky. And perhaps investing in a big factory is a bit more risky, obviously, since you have a great or a big outlay and you never know what the future will show you. So this interest rate is referred to as discount rate or cost of capital or hurdle rate. It's all the same thing, so don't get confused if we use different words for the same thing. And next up is the net present value. Johan talked a bit about the net present value and that it was the present value of the positive cash flows minus the present value of the negative cash flows. So generally when you take an investment decisions, you give up resources today, which is then the present value of the negative cash flows, in the hope of obtaining some positive cash flows, which is here. So if you calculate the present value of the positive cash flows and deduct the present value of the negative cash flows, you get the net present value. So you can say it's the present value of all cash flows. And it's, as I said, net present value. It's called that because it's the net present value, obviously. So it could look like this. It could be that we invest 300 today and we get 80 every year in 5 years' time, for example. So in order to decide if this investment is a good investment, we need to calculate the present value of these cash flows. And these cash flows, since they are of equally big size, and since it is exactly one period between every cash flow, it's called an annuity. We get to that later. But as I said, in order to compare the positive cash flows to the negative cash flows, we discount it till today by using the formula that we have. So we use this formula down here in order to decide if it is a good investment opportunity or not. So we can start with discounting, as we say, all the positive cash flows. And we got 80 after 1 year. So we take 80 and divide by 1 plus the interest rate, which is 15% in this case. Raised to the power of 1 since it's 1 year. And if we calculate this, it gets approximately 69.565. So then we take the next year and do the same thing. We take 80 divided by 1 plus 0.15 since the interest rate was 15%, raised to the power of 2, since it's in 2 years' time. That's 60.49. And we take the next cash flow, which is in 3 years' time, also 80. The same interest rate of 15% raised to the power of 3, since it is in 3 years. And that is 52.60. Sorry. And we take the 4th year. We get 80. And we divide it by 1 plus 0.15 once again, and raise to the power of 4. And this is 45.74. And lastly, the last cash flow, which is 80, and it's in 5 years, so we divide by 1 plus 0.15, raised to the power of 5. And that is approximately 39.77. So if we sum these up, all the positive cash flows, denoted by sigma, we get 69.565 plus 60.49 plus 52.60 plus 45.74 plus 39.77, which is approximately 268. So if we want to get the net present value of this investment opportunity, we take the present value of the positive cash flows, which is 268, and deduct present value of the negative cash flows, which is the initial outlay. And that was 300. So if I write here, net present value is equal to 268 minus 300 is equal to minus 32. So we can conclude that this investment got us a net present value of minus 32, which is not good. The company will decrease in value if we do this investment, why we obviously will not do it. However, I think this was quite boring, and I think you also thought it was quite boring. You perhaps imagine, but what if it's 20 years or 50 years? I mean, I can sit here and calculate for all day. No, that's completely correct. And that is why we will go to a model expansion, or we will expand the model. We will have the present value of an annuity, which allows us to compute the present value of an annuity with a single formula. So we don't need to calculate the present value of every cash flow by itself. And for this we have some requirements. First of all cash flows, well, except the initial outlay, needs to be of equal size. So as in our example, every cash flow was of the size 80, so that's fine. And it has to be equally long between every cash flow. In our example, it was 1 year between every cash flow, so it's also fine. This was an annuity, as I said before. So if it is like this, if all cash flows are of equal size and it is equal long between every cash flow, we can calculate the present value of this annuity with one single formula. So it transforms every future cash flow to a single value one period before the first cash flow. And I highlight this because it is very important that you remember. So if the first cash flow comes in 1 year, as in our previous example, we move all these cash flows till today, 1 year before the first cash flow. But if the first cash flow comes in year 5, we move all the cash flows to year 4. It's just good to remember, since you might have to, you might not be done with the calculations when you have done the present value of an annuity formula, so to speak. So in our example, we move all the cash flows at the same time, which is a lot better, or it takes less job. This is the formula. So in order to get the present value of this annuity, this stream of equally big cash flows, we take the first cash flow, and it's important that it's the first. It's not important that it's the first, that's later on, since all cash flows are equally big. However, you take the cash flow, in our case 80, you divide by the interest rate or the discount rate, and you multiply this with this whole factor, 1 minus 1 divided by 1 plus r, again the discount rate, and this raised to the power of n, which is the amount of cash flows. I write that down. So it's not the amount of years you want to move it, it's the amount of cash flows. So in our case we had 5 cash flows, then n is 5 in our case. And in the formula sheet it will look something like this, where PV is the present value, or short for the present value. And once again you take the cash flow divided by the interest rate and multiply by this factor, 1 minus 1 divided by 1 plus r raised to the power of n. So if we apply this formula to our example, we just get the present value of the positive cash flows to start with, and it was 80 divided by 1 plus the interest rate, which was 15%, so 0.15. Sorry, not 1 plus, it should be only the interest rate, so 1. So 15%, 0.15, multiply it with 1 minus 1 divided by, now it's 1 plus the interest rate, so 0.15, raised to the power of 5, since it was 5 cash flows. So if we type this into the calculator, we will get approximately 268, which is of course the same as we got before. So in order to get the net present value, we take present value of the positive cash flows, 268, minus present value of the negative cash flows, which is the initial outlay, or 300. And we get minus 32, as before. So we can now continue to another example. And here it says that an old teaching assistant is looking to sell solutions to old exams. This demands her to refrain work that would have given her a present value salary of 100,000. She estimates that she will be able to sell solutions worth 10,000 each year, in 20 years' time, and she uses a discount rate of 10% when evaluating investments. Is this a good investment? Or in other words, what is the net present value? So just as a reminder, it's always good to start off by typing down all the information so we don't get lost. So the annual net cash flow, the positive cash flows, we start by calculating the present value of these using the present value of an annuity formula. So we take the cash flow, which is 10,000, divide by R, so 0.10 in this case, and multiply it with 1 minus 1 divided by 1 plus R, which is 10%, and raised to 20, since it's 20 cash flows. And if we type this in, we should get approximately 85,136. So if you want to know the net present value of this investment opportunity or this business idea, we take the present value of the positive cash flows, which is 85,136, minus the present value of the outlay, or what she couldn't work for. So minus 100,000. And we get minus 14,864. Well, you wouldn't work for minus 14,000, so obviously this is not a good investment, or this is not a good business idea as it looks at the moment. It is better that this teaching assistant does her regular job and earns the present value salary of 100,000. So lastly, we can have a final example. And here, a guy called Jan Lindgren have been offered $14 million for the lead role in the coming 3 Larry Boy movies, which is paid out when the contract is signed. If Jan accepts this offer, he must refrain other roles that would have given him $5 million in the end of every upcoming 3 years. Also assume that Jan's cost of capital is 10%. And the question is, what is the net present value of taking the lead role in the 3 Larry Boy movies? So we start with typing down what we know. And I think it's good to also make a timeline. If it's 20 years, it could feels as a lot of work to do. However, I do recommend you to do it because it's sometimes easy to move the cash flows 1 year earlier or later than you want to, or something. It's always good to do. And here it's 3 years, so it's definitely worth doing. So we said that looks something like this. The sign-on bonus, or basically it's better to make it like this perhaps. The sign-on bonus was $14 million, and this made him refrain work for $5 million in the end of every 3 years. So this is pretty much what the investment looked like, or the lead role in the Larry Boy movies. You either get $14 million today, or you do some other work and get $5 million each year, with the start in the end of the first year. So here, if this is the first year, this is the second year, this is the third year. Then you can think that you get 5 million last December in the first year, and you get 5 million the last December in the second year, and you get 5 million in the last of December the third year. As usual, in order to compare these two, you need to calculate the present value of these 3-year salary. So if we calculate the present value of these, we use the formula and have the cash flow 5 million divided by R, which is 0.15. Sorry, it was 10. You multiply with 1 minus 1 divided by 1 plus R. Once again 10%, not 15 as I said. And it's 3 cash flows. If you calculate this present value, you will get 12,434,000 US dollars. And you can now compare the present value of the positive cash flows with the present value of the negative cash flows. In this case, it's perhaps not a negative cash flow, but it's cash flows that you would have given if you didn't take the lead role. So it's the alternative. So you take net present value, which is equal to 14 million minus 12,434,000. And you get 1,565,000 approximately. Actually, you get 66. So this is basically the net present value of taking the lead role. You get a bit over 1.5 million US dollars in present value terms, which of course we see as a good investment, and Jan in this case should take the lead role in the 3 Larry Boy movies. So to sum up, a series of equally big cash flows are called an annuity. The present value of such an annuity is calculated as follows. To get the present value, you take the cash flow here. You divide by the interest rate or the discount rate. And you multiply this by the whole factor 1 minus 1 divided by 1 plus R. Once again, the discount rate, raised to the power of n, which is the amount of cash flows in the annuity. So if the annuity have 5 cash flows, n is 5. If it's 20 cash flows, n is 20, and so on. And last of all, you need to remember that all cash flows, except for the initial outlay, needs to be of equal size. And it has to be equally long between every cash flow, and the value received is in one period before the first cash flow. And that was all for today. Thank you very much. Good luck.